Is the helicopter dead? After all that footage we see from the Russo-Ukrainian war, we may very well think so. Yet many countries have doubled down on the helicopter. Germany is getting 145s and Chinooks, Poland is going with Apache, and the US, well, more Blackhawks and the Valor. And in this video, you will see what could be the future of the helicopter. Before that, some context. Various countries in NATO launched NGRC, Next Generation Rotorcraft Capability, to develop a joint medium multi-role helicopter to come into service after 2035. What is NGRC meant to do? It's NATO, so the list is long. First off, this helicopter is to substitute current medium helicopters like NH-90 or Merlin. That means air assault, spec ops, airlift, medevac, search and rescue, ASW, and so on. And there are steep performance specifications coming with this. Endurance 4.5 hours, ferry range 900 nautical miles, cruise speed 220 knots, which for a helicopter of this class is really knocking it out of the park. The small print, we will get to that in a minute. For now, 3 companies are working on NGRC, and I got the opportunity to check one out. So, America, here I come. This is Raider, Sikorsky's entry into the running. Now the overall shape and size may be familiar to you if you've seen the S-97 or the Raider X for the FARA program. And Sikorsky believes that this is the ideal template for NGRC, and we're allowed to take a closer look. The Raider is a fast and maneuverable coaxial compound helicopter. That means that unlike a conventional helicopter that has a single rotor up top, this one has 2, and they spin in opposite directions.
On helicopters, when you start going fast, half of that rotor disc is going the opposite direction that you're going. A lot of that airfoil that's going the opposite direction as you're going, it hits the airflow going the wrong way over the airfoil, and that's no way to make lift. And so when you have 2 rotors, one on top of the other, each turning the opposite direction, now you've got 2 advancing halves of discs, and you can rely on the really good lift that you get out of that half of the disc in order to go fast and balance them with the upper rotor and the lower rotor.
And then in the back there's another surprise. We don't have a conventional tail rotor. We actually have this, a pusher prop, and that propels this aircraft to over 200 knots. And in fact, on the X-2 technology demonstrator, they have reached speeds close to 250 knots. And I find this really cool because it harks back to that experience that Sikorsky has gained with compound helicopters in the past.
Only 10% or so of the power is being utilized by the main rotor. I'll use the prop to help me to accelerate and decelerate. You, as the pilot, are controlling your power with the pusher prop, which is just a beeper on the collective. Push forward for more thrust, aft for less thrust. At 100 knots, you feel the collective kind of tug on your hand, and that's the flight controls saying, I got the collective, don't worry about it. And the collective moves to the most efficient position that the rotor, for the rotor at the speed that you're at. And then you climb and descend with just adjusting your pitch attitude. And so you'll adjust the pitch attitude up if you want to climb, and add a little bit more thrust to the pusher prop in order to climb, and conversely to descend.
So a question that a lot of you may have now is, this is a new platform, how mature is that technology? Well, the airframe itself has hundreds of flight hours, and there's thousands of hours in the simulator. And a lot of this stuff goes also back to the experience that Sikorsky gained with the 53 fleet. However, if we look at a mock-up here, a lot of this is still work in progress, subject to change, depending on what the customer nations want. But some things are going to be clear. There's going to be space for soldiers, there's going to be space for medevac, NATO standardized cargo. So let's start talking about the small print: connectivity, kinetics, and autonomy. Sensors and data are vitally important. We know this. If you're one of the operators here, you of course need to see the battlefield. You need to know what's going on. But how can we nowadays, with the contested electromagnetic spectrum that we're seeing in conflict zones, make sure that we can gather data, process it, and then vitally, of course, share it between platforms? Basically, we get to what in NGRC terms is called network-enabled operations. First of all, you gather data from cross-domain sources. So you have sea, land, littoral, and air. And as you're gathering that data, you're of course building up a network between these different platforms. And yes, some of those linkages will invariably be cut by an adversary. But because it's a mesh network, you can jump from one node to the next. You're building up is a situational awareness picture for the pilot of not what is just happening in their vicinity, but also beyond the horizon. And this, of course, requires processing and subsystems that are able to do so. However, beyond that, you also have execution support by AI. And I understand that nowadays AI is just a buzzword for everything. But really what's happening here is that the workload on the operator is meant to be reduced. What they have to say to the system, to the platforms that they are cooperating with, is, I want this task to be fulfilled. Then everything, all the individual steps that have to happen for that to be fulfilled are done automatically and even adaptively to different situations, depending on what system we're talking about. And that takes a lot of workload away from the human, who, yes, stays on the loop, but only really has to push one or two buttons in order to have that oversight, and everything else is done autonomously. And for this, Sikorsky might even have a joker card, because they can of course draw on Lockheed Martin's unidirectional mail data link that the F-35 is already using. So something like this could communicate directly with the F-35 platform and back.
You know, when I started flying a long time ago, I don't want to say how long ago, but it was a long time ago, like we didn't even have GPS in our aircraft. Now, you know, one of the capabilities that we have based for GPS is ADS-B. Look down on your iPad at a moving map and see real time all of the other traffic that's out there in the airspace. And the same transcends into a combat machine, that current situational environment that you can pull in of the threats and the friendly forces, that it just enhances the crew's ability to complete that mission safely, effectively, and with less risk.
Then let's talk kinetics. Are there going to be guns? Will missiles be hanging off this one? Yeah, most likely. But NGRC actually focuses on something completely different. That is air-launched effects and collaborative UAS employment. Basically, the chopper needs to be able to cooperate with a variety of drones and even be able to launch them. It becomes, in essence, a parent ship. That allows one single machine to cover a much wider area. You can have effectors that are kinetic or just there for reconnaissance. There may be decoy targets, or they're there for electronic warfare support. And all of that increases the survivability of this platform because it can be at a more standard range, while simultaneously increasing the mission spectrum of what can be done. And it also creates dilemmas in the adversary and restricts their freedom of movement.
Depending on what that air-launched effect is and what sensors it has on it, and being able to put those tentacles out there and control it yourself, or even hand that control off to somebody else, it just multiplies the effectiveness of that platform. An incredible capability to not have to take your main asset over the horizon that you may not want to go in a particular place before you know exactly what's there.
Let's talk about autonomy. Now, the way that conventional rotor wing has worked so far is pilot takes off, drops off a couple of soldiers at a landing zone, flies back, debriefs, has a rest, prepares for the next mission. End of. But maybe that is not the end for NGRC. What if during that off time, this platform can be used uncrewed? Maybe it can do some airlift, transport cargo from A to B unmanned, alone or as part of a larger formation. In that formation, perhaps there's one single helicopter that is crewed as sort of human oversight, and then behind that, linked to that first helicopter, is a swarm of choppers that are uncrewed, and they're just going to bring supplies from A to B, or they're ferried from A to B. And that frees up the human. And also, there are certain mission sets where maybe the human isn't supposed to be put at risk, or is just not required. And that's the capability there. And beyond that, there of course are also now in the works systems that are designed from the ground up to be uncrewed. So that is in NGRC terms called crewed uncrewed teaming. And it's going to be really interesting to see where that level of autonomy and that level of human oversight and the ability to really not put humans at risk in certain situations is going to take us in the future. But of course there are certification and regulatory challenges there as well, and those policies do apply. So watch this space.
All of the X-2 aircraft that we've made, and we've made a number of them now and designed a number of others, have a fly-by-wire flight control system in them. In fact, that's one of the enabling technologies of this aircraft, that back in the 1970s, we built the Advancing Blade concept aircraft. And one of the issues was the workload was pretty high for the pilots because there were a lot of things that they had to do as they changed the flight regime from low-speed flight to high-speed flight. right? From the difference in torque on the main rotors providing yaw control to the rudders providing yaw control. All of these things, the pilots had to do something different, whereas now it's all automated and it's so easy for the pilot. In fact, most of the time when I'm flying this aircraft, I don't even have to have my hands on the flight controls, and it's absolutely holding the last condition I told this thing to hold. And so with that in mind, that's the perfect backbone for an unmanned vehicle, that now you add a few extra sensors to the machine to make this unmanned and go out there and do the mission that you need it to do. And again, is it risk? Is it manpower that you have a shortage of, that you don't have the people to take that aircraft out and do that mission? Or is the mission too risky that you don't want to send people out in it? But there's also missions where when there's people in the back of that machine, you probably want the best qualified pilots to react to contingencies that you weren't anticipating before you went on that mission. And so I think it's a great capability with the fly-by-wire system that you don't have to add much to have the unmanned capability on the machine, and it adds a lot to the force.
So I spoke a lot about the ideas behind NGRC and what it could be. But let's ask the awkward question. Whatever it's going to be, it needs to be operational, and the availability for squadrons to scramble as many birds as possible needs to be there. One of the things you of course do is try to design the aircraft to be easy to maintain and everything is easy to access. But at the same time, there's also a diagnostic element to this, where you really want to check in with the machine and see how it's doing and where it may need some overhaul. And some of you might be familiar with what is coming next. It's called a digital twin.
Right, so the sustainment digital twin is our virtual representation of each individual aircraft. So this carries all the metadata, the part data, the maintenance history, everything like that right there at your fingertips.
So if I was a maintenance guy now with a squadron and I wanted to check in on the aircraft, let's say the engine, what would I do with the software?
It's designed to be able to use on a tablet, a laptop, anything that's in your hand. What we're in now is the X-ray view, so you could isolate right in on the part that you selected. And it doesn't have to be a big component like your engine. It could be any piece that's in your bill of materials. So what we would do here is we'd open our condition-based maintenance window. And for this specific aircraft, it's focusing on the tail gearbox, and this is saying you have 120 hours remaining on that gearbox. That allows the maintainer and their planners to forecast ahead of time, move that. In the past, that would have been an unscheduled failure when it comes in. Now we'll be able to plan ahead and order those parts ahead of time and prepare for that maintenance.
It's a very nimble aircraft, and like you've got this rapid roll response that you can get out of it. So so if you come from the left and do a rapid turn to the right, you can get a sense of like how quickly you can roll in it, and that means you're going to have confidence to operate closer to the terrain and lower to the terrain, and all of a sudden there's wires there and you can pull aft and climb up. Compared to other rotor helicopters and in particular tilt rotors, it's going to be a much faster response that you're going to get out of these very rigid rotors. That in large part, these rotors have to be rigid because they're operating in the opposite direction of each other, and so they have to be rigid to keep them separated. But that rigidity also provides amazing control power to you as a pilot, and reduced control response time. You can operate at treetop level, I think, with somebody who's got the right experience level at 200 knots. But if you go to 250 knots, gosh, I want like 20 or 50 feet above the trees because I get uncomfortable at that speed. And there's a big difference in, I think, survivability as well. That if I'm 20 feet above the trees at 250 knots, I still feel like I'm challenged, and I'm doing a lot to make sure that I stay clear of the trees and the terrain and the obstacles that are out there. But if you go to 200 feet above the trees and terrain, you could probably do 500 knots and have confidence that you've got enough altitude clearance. So it's pretty subtle that what is the right speed versus the altitude. And I feel like, if you can do 200 knots at treetop level, that's kind of the sweet spot of human capability
Yeah.
and the cross-section of the aircraft capability as well.
I mean, that brings up the whole discussion about automatic flight autonomy in these machines as well.
Right.
Of what has the human to do in this machine now, and what is the technology capable beyond that?
Terrain flight and avoiding all of the obstacles, like a computer could do a really good job at that. One of the things I think that I do as a pilot, if you've got people in the back, you're a little concerned with the ride quality and not jerking them around unnecessarily. And so you're making decisions on not just avoiding all of the obstacles out there, but trying to make the ride quality such that everybody's not sick when they get where they're going.
I think they would be very unhappy with me right now.
Maybe. And you'll see a maneuver in the demo where we do this, put a bunch of negative pitch on the prop. And, if you're an attack ship,
oh, yes.
and you're nose down, you get a real tight beaten zone of whatever your weapons are if you're firing like a gun or unguided rockets. And so the ability to have a lot of time to look at the target is nice. And then you just reverse the prop forward and peel off the target.
And that's the rear push, the pusher prop that
Right.
provides
We're
that,
able to
yes.
use it as a brake going
Right.
downhill so that we're not accelerating like crazy going down the hill as well.
Wow. All right, so we're waiting for the flight demo, and the VIPs down there have absolutely no idea what's going to happen. But apparently, a radar is going to sneak up on us and appear out of nowhere. So I'm going to see if I can spot it. Yeah, I can see it. Oh, that's fast. Oh wow. Oh wow. Holy crap. Heiliger Schlawiner. Left bank now into a climbing turn. So what we're going to see now, I think, is the level bodily acceleration of radar. So it's going to come out of that turn. It's going to go straight and level. It's not going to pitch the nose down and compensate with the collective to accelerate. It's just going to go straight and level with that pusher prop all the way up to 180 knots. It's like a high-speed pass from a jet, just that this is a helicopter. There it comes. There it comes. Oh, that's a beautiful sound. That is a beautiful sound. Wow. That sound reminds me of the warbirds of World War II. That is awesome. Right, they're coming back in and they're gonna set up a climb here. There we go, coming in. Using all that power from that pusher prop to accelerate and then go into that climb. Oh. Look at that thing go. Now that they're up there, perfect position to show off a gun run. So what they're going to do, and this is really cool with the pusher prop of course, they're going to come back, go into a dive, and that pusher prop is going to give us negative thrust. That keeps the platform on the target for longer and just have a really good beaten zone down low. Looking forward to this. We tried this in the simulator and it looked awesome. And they're about ready to dive. There they come. Yeah, so it's nose down, negative thrust, almost like an air brake. And they're just keeping on target. Now just imagine rockets, guns. And they're leveling out. And I think the next thing we're going to see is the deceleration. So we're going to come in fast. And then they're going to use that pusher prop once again to brake the aircraft very quickly. All sorts of advantages. You can change speed quickly, you can decelerate, you can accelerate. If you see a threat pop up on the horizon, you decelerate, go into your turn, accelerate out of the turn. Much faster than a helicopter of equivalent size. There we go. It's coming in fast. You can hear the difference in sound now that it makes that they're braking. Extending their landing gear as well, slowing down really quickly. And look at that, they don't actually have to put up their nose either. When you slow down a helicopter, typically you you have to pull up that nose, you have to compensate with the collective, and while you're in that nose-up attitude, you don't really know what's going up in front of you. This can decelerate in level attitudes. And now they're going backwards in level attitudes. Just imagine that if you're down low between the trees, treetop level, and trying to navigate tight spaces. We're going to see some more of that close-in maneuverability, I think. And they can do a hover, nose up. Nose up hover is possible, nose down hover is possible. Again, that provides maneuverability and also the ability to look in places where another conventional helicopter wouldn't be able to do it. Oh, notice that switch in sound there. Push-up prop is off. And now it's miraculously silent for a helicopter. It's not far out. Obviously I can hear it from here. But imagine some obstacles between us. Oh, look at that. That was near silent, that spin. You're a little bit more distance between me and that helicopter, and I would have trouble, picking it up. And I think now they're going sideways. I think yesterday they told me they tested this up to 30 knots already. That is smooth. That is really smooth. Gotta tell you, it's really exciting seeing something like this, knowing that this could be the future of helicopters. Being part of seeing something like this for the first time. Swinging over now, circling. Background of all the trees and so on. Just imagine that helicopter darting in and out of the trees, going up, down, into different pockets. Right, this might be the final pass here. It's going to be another high-speed pass. It's coming straight at us now. And with it being frontal aspect, I actually don't hear it yet. Now I'm starting to hear it. Oh, it's coming in. Oh, that sound. Ooh, that sounds dangerous. High-speed agility as well, going into a brake turn to the right. And again, that high-speed agility, just think about how useful that is. If you're going fast at treetop level, a threat pops up and you have to, get out of there. Compared to a conventional helicopter of the same size and weight, that was quick. Oh yeah, pedal to the metal. That is awesome. That is just beautiful. So a big thank you here for all of you watching, and of course Sikorsky for giving exclusive access to this machine. If you have any sort of questions about radar and where they want to take this, do put it in the comment section. And also please let them know that you're really appreciative of this access, because I can take both of those things, turn around and go back to them and create hopefully future content for all of you where your questions will be answered as well. So as always, have a great day and see you in the sky.
As a bonus, check out our second channel, AirPower 21st Century, for full simulator video and the full flight display of X-2 radar.